Hi everyone. So today's topic is atoms, molecules, and states of matter, which is connected to the thermal energy and heat stuff that we've been talking about so far this unit. So there's going to be a bunch of vocabulary words and some notes to take down on states of matter. So take a minute to get your notebook out in front of you or to open up your online science journal and make sure that you're taking these notes down so you have them for later. All right, so the first vocab word is atoms. So atoms are the basic unit of all matter. You've probably heard of these before. You've also heard of cells before, right? Cells are the basic unit of life, and atoms are the basic unit of everything. So atoms are way, way, way smaller than cells. Yeah, and they make up everything that you can see, touch, everything in the universe. All right, so I want you to estimate how many atoms do you think are in your body based on what you already know about atoms. Take a minute to think about it. Try and come up with like a logical answer on that. Okay, now multiply your estimate by about 200 billion, and maybe you'll be close to getting it right. So one hint here is that in a single cell of our bodies, there are 100 trillion atoms in just one cell. So just want to put all those zeros in front of you. So one cell, 100 trillion atoms, which is, in other words, we can say the number of atoms in one of your cells is about how many grains of sand are at your average beach. Okay, molecules. So molecules are groups of connected atoms. So two or more atoms together make a molecule. And there are a lot of different combinations of these of these molecules. And a couple are down here. So this is an oxygen molecule. That's two oxygen atoms. This is a water molecule. You guys have heard of H2O. That's because there's two hydrogen atoms, these blue ones here, and one oxygen atom. This is a salt molecule. Actually, that's a bunch of salt molecules. And then I think the one hidden back here is a glucose molecule, which is what's made during photosynthesis. Okay, some notes on states of matter. So states of matter are gas, liquid, and solid. And then there's also plasma, but we're not really going to talk about plasma because it is the rarest state of matter, at least of what we see on Earth. An important thing to know about states of matter is that substances will change state when they lose or gain thermal energy. So this is when we're connecting it back to the thermal energy stuff that we've talked about so far this week. So take a look at this diagram. This is a solid, let's say it's ice, okay? As we add thermal energy, these molecules are going to move faster and faster and faster until they eventually turn into a liquid. They melt. And then you can see that these molecules have some like movement parts on their diagram. So these molecules are moving faster than they were when they were a solid because they have more thermal energy and more kinetic energy as a result. And then if we heat it up even more, that water would eventually turn into water vapor, which is a gas. Whereas if we took out thermal energy from the gas, it would turn back to a liquid. If we took more thermal energy out of the liquid, it would turn into a solid. All right, so a little bit more about each state of matter. I know you all know what a solid, a liquid, and a gas are, but you need to know these little parts about what defines them really. So the solid is the lowest temperature state. Molecules have little kinetic energy. So when I say molecules have little kinetic energy, let's take a look at my pen, right? This is a solid. However many, let's say 200 million molecules in this pen, they are all moving a little bit. Even if I hold the pen still, the molecules are like jostling around just a little bit on a very, very small microscopic level. So they have a little bit of kinetic energy. And the other thing that we know about solids is that they have a fixed shape and volume. This pen is not just going to like change its shape as I move it around, right? If we melted it, which we could, I suppose, it would change its shape. but not if it's remaining a solid. All right, liquid. So the temperature is higher than a solid. The molecules in a liquid have more kinetic energy than they do when they're in a solid, but still not like a ton of kinetic energy. And they have a fixed volume, but a changeable shape. So if I hold my water bottle here, the amount of water in here is not going to appear to change, right? It's going to stay at that same level. However, I can change its shape if I just, oh, and of course I just spilled it. I can change its shape if I just move the water bottle around a little bit, and that's because this is a liquid, and that's one of the definitional parts of being a liquid. All right, and then gas. So gas is the highest temperature state that we're talking about. Molecules have a lot of kinetic energy when they are a gas. So they're moving around a lot, they're bumping against each other, and gas molecules have a changeable shape and a changeable volume. So if you have ever blown up a tire in a bike, then you've kind of seen this, because if you have a pretty flat tire on your bike at first, there's a certain amount of air in there, right? A certain amount of gas. And then if you pump up the tire, you're adding more air into the same amount of space, but there's going to be more packed in there, okay? All right, and I think that's all I have to say about gas. So let's do a quick review just to tie together these concepts in this video, because there's a lot of them. First thing, atoms are the smallest unit of matter that we have. Molecules are, roughly the same size, though multiple atoms combined together, but these are still really microscopic, right? As long as it's more than one atom connected to another, you have a molecule. Then we have the three states of matter that we're going to be talking about. So a solid, liquid, and gas. You can see the molecules here lined up together in a solid. In a liquid, they're kind of more spread out. They have more kinetic energy because they are warmer. And then in the gas, they have even more kinetic energy because they are even warmer and they have more thermal energy. And so they're even more spread out. All right, and then last thing, I wanted to close out that estimate thing. So if you did some calculations like I did, then you might have figured this out. The number of atoms in a human body, in like an average human body, is about 10 octillion, which is a 1 with 28 zeros. So hopefully that gives you an idea of how small atoms and molecules are. It's pretty tough to imagine, but hopefully that helps. All right, do the Google form that's attached to this, and I'll see you in class.